Hi, Dave Littman, Truth in IT. Welcome to today's webcast, How to Cache for Mission-Critical Applications at Scale. Today's webcast is sponsored by Redis. And in just a second, I'm going to be handing things over to Mike Matchett. Mike is CEO and Principal Analyst with Small World Big Data, and Mike will be joined by John Noonan, Senior Product Marketing Manager with Redis. We expect today's event to go about 30 minutes, and we'll be taking your questions and comments in the chat room. We've got folks standing by from Redis to answer those questions. So without further ado, let me hand things over to Mike and John. Mike?
Yeah, thanks, Dave. No, this is great to be here today with Redis. We are talking with John. Welcome, John.
Thanks, Mike. Glad to be here.
We've talked about caching before. Caching at one level seems like, everybody's got to do it. Everyone has it. But today we're going to dig deeper into what makes an enterprise-grade cache, what makes it a professional cache, caching when it counts, I guess we might say, right? How do we cache for the mission-critical applications at scale? Let's just start a little bit about, what's the real motivation for cache? I mean, everyone knows it's speed, but there's more to it than that, isn't there?
Absolutely. Yeah, so let's start. We'll take it a step back, and we'll just touch briefly upon why caching matters and why it's needed. Surprise, everyone, we're living in the age of real time. I think we all know that already, though. The fact is, we live in a digital world. Business and society at large are exponentially shifting toward a digital-first model. Applications are primarily turned to for an ever-increasing variety of functions. I mean, think about your own lives. Everything from hailing a cab to booking a restaurant or depositing a check is now just done digitally. And in order to win in this new paradigm, applications have to be able to do a few things in order to meet customer and user expectations. They have to be incredibly scalable in order to support both sudden, unexpected spikes in traffic, as well as gradual business growth. They must perform in real time at all times. Users honestly just no longer have the patience to wait for apps to load. And because competition is always just a click away, slow apps have significant business implications. In today's age, latency is really the new outage.
Right. We know. Yeah, I was just gonna say, we know psychologically, if we're web surfing and something takes an extra second, I'm off to the next website, right? I'm gone, exactly. Right? Yeah.
Exactly. So in this age of real time, with these real time user expectations, a fast database is an absolute necessity to reduce latency and keep your applications performing as expected. Any millisecond spent on the database has been measured to have a 100 times impact on users downstream. So because of this, the fact is that real-time apps absolutely start with the database.
And so we're going to talk about this, but I know we're back to speed being the primary driver here, but it's not just speed in terms of delivering back that one transaction or that one image, right? Because that's what most people think of the cache, some content delivery cache. But we've got a lot of complexity going on in today's applications, right? We've got different layers, and they all might need caching, and they all add up. So if you're not delivering speed at every layer there, that total latency can really drag you down. So it's not really about the single access thing. It's about these complex applications too.
Absolutely. And the real-time application performance set that users expect just absolutely starts with the database. And any latency there is just completely cascades down the entire infrastructure and can lead to terrible outcomes for applications and for users.
All right, so everyone watching this is probably familiar, at least with the brand name of Redis, but tell us a little bit about how businesses approach this caching need and where they plug Redis in and where they consider it.
Yeah, absolutely. So businesses have this need for speed and they need real-time application performance, but there are actually a number of challenges and constraints that they're dealing with. The first is that databases today, they're just too slow. I mean, even the fastest databases just can't meet the application requirement for sub-millisecond latency, which leads to applications with poor performance. The second challenge is that businesses typically have legacy applications and they have technical debt. So it's really just not realistic to completely scrap everything and start over to increase speed. They need to speed up their current applications without a complete overhaul that disrupts their operations, impacts their customers, or costs them a ton of time or a pile of money. And finally, even if they could find a database that did meet their need for speed. Businesses often have complex data layers. They typically use multiple databases for each use case. They'll have a relational database for structured data, a graph database to analyze relationships, key value databases for unstructured data, and so on. So even if they found a database that was fast enough, it would only partially solve their latency issue in such a complex environment. It might, it might work for one of those data types they're working with, but not all. So the good news is that caching with Redis offers an excellent solution to these problems. Using Redis as a cache is an incredibly popular and common method to speed up application data responses and meet those those user expectations for real-time performance. So a Redis cache can really work alongside just about any type of database, allowing you to store your most frequently accessed data in RAM and achieve the sub-millisecond latency needed for real-time applications. And it also greatly improves performance without the need to completely overhaul applications. A cache can work really well alongside an existing database with minimal effort and greatly boost data performance.
All right, so it's clear that we need some caching. It's clear that the database is maybe the right place to stick the cache in when we're first looking to do this. And Redis is a well-known solution for this, but what is Redis? Help us understand, like.
Yeah, absolutely. So yeah, as I mentioned, using Redis as a cache can help businesses meet these performance requirements. But let's talk a bit about what Redis is. Redis is an in-memory data store, which means that data is kept in RAM so that it's lightning fast. It's most widely known as a cache, but has really since evolved into an incredibly popular and widely used real-time database. Redis is incredibly flexible, and it's able to support just about any data model, from key value to JSON to graph to time series and even more. And this means that Redis can greatly enhance the speed for just about any type of database. And just because of its speed, its flexibility, and its overall capabilities, Redis is one of the most widely used and most loved database technologies in the world.
Oh, so maybe I wasn't understanding myself. This isn't just for SQL kinds of things, or even document databases or databases. But you mentioned you've got other kinds in there. You've got graph, you've got time series, other things. So are those separate technologies in there, or is all part of the enterprise level of
It's
this?
all part of Redis. So yeah, Redis
Okay.
can work with just about any type of data model, just about any type of use case.
Okay. Very cool. So let's just help us. And I say us, the audience here. And by the way, audience, if you've got questions, put them in the chat there. We've got some people standing by to answer them. What is a cache actually doing? How does a cache actually work before we dive into what Redis is doing with caching?
Yeah, so I mean, at its core, database caching is a simple enough concept. It's basically the practice of putting an in-memory data store in front of or aside a database, which acts as the system of record. So caching allows organizations to store critical or frequently requested data in lightning fast RAM to enhance application performance by reducing calls to the slower disk or flash-based databases. So you see in this diagram shown here, this is an example of an application cache where the application makes a data request from a primary database. The data is then returned to the application, but it's also loaded into the cache. So for future requests, this data will be served directly from the cache to greatly increase application performance, as well as reduce some of the load and some of the burden on the primary database.
Okay, so this is usually running closer to the application in at least in terms of performance. So this is something that you generally place in front of that,
Exactly.
and
Right. The data will come directly from the cache to the application with the sub-millisecond latency, instead of incurring the greater latency of being requested from a slower disk or flash-based database.
Okay, now there's different kinds of data, John, and I've been in the storage industry a long time, and I know there's some different ways to implement caching, even though you've shown it simply here, because data is changing and sometimes data is streaming and things like that. So, how does something like this actually get deployed in those different scenarios where data may be taking a different shape or have a different speed?
Yeah, that's a great question. So I just showed kind of the simplest iteration of a cache, but there are a lot of different ways that our customers use Redis as a cache for all different types of application use cases. So let's take a look at some pretty common caching patterns, as we call them. The first is a cache aside or lazy loading pattern. This is the most common way to use Redis as a cache. With this caching pattern, the application first looks to the cache to retrieve the data. If the data is not found, and which is called a cache miss, the application then retrieves the data from the database directly. So data is loaded to the cache only when necessary, hence the name lazy loading. And this approach can really help boost performance with read-heavy applications.
Okay.
The next pattern is write behind or write back caching. With this strategy, data is first written to the Redis cache, and then it's then asynchronously updated to the database. This approach improves write-heavy performance and really eases application development, since the developer only writes to one place, which is Redis, and then it's asynchronously updated to the database. Similarly, in the third example, we have write through caching, which is similar to the write behind approach, as the cache sits between the application and the database, except the updates are done synchronously. So this pattern favors data consistency between the cache and the data store, as writing is done on the server's main thread. And then finally, you have read replica caching. A read replica approach to caching helps boost performance where there is a large amount of historic data, or there's a requirement that each write must be recorded on a database. Read replica caching captures individual data changes and propagates exact copies without disrupting ongoing operations with near real-time consistency.
Okay, so there's a couple of complex architectural things you can do with caching, depending on your particular need for balancing absolute control of that data, absolute capture of the data versus performance, and
exactly.
Yeah,
and also different types for if you're trying to offload a read burden or a write burden, you can either read directly from the cache or write directly to the cache. So there's a whole different. I mean, this just scratches the surface. These are the most common ones, but there's tons of different ways that a Redis cache can be used for faster application performance.
Okay, really great. I know that there is obviously open source Redis. Almost everyone I know uses it in some way. I think I even have something running here that's the Redis. I think I've probably got 5 copies of it myself. But we're here today to talk about some of the more advanced capabilities, some of the things that you need to have if you're going to rely on it at an enterprise level.
Yeah.
Let's get into that. Tell us a little bit about kind of the types of caching you see. How do you think about that? And when you're talking to customers?
Absolutely. Yeah. So I mean, we touched upon some of the different ways that caches are used. But there's also a lot of different types of caches. So we really typically classify caches into 3 basic buckets or categories: basic caches, intermediate caches, and enterprise grade caches. And businesses can take a basic approach to caching if they're doing something simple, like let's say self-managing open source Redis. They can take an intermediate route with a cloud managed service, or with maybe an in-house team that manages Redis with a greater degree of competency and has a more organized Redis operation and support strategy in place. Or they can utilize a full enterprise grade cache that has all the functionality that goes beyond open source caching, and provides things like global scale, ultra high availability, better cost savings functionality, and also is supported and managed by experts at Redis. So each type of cache is different and has scenarios where it's a best fit. So you wouldn't want or be able to support an entire enterprise application with a single self-managed open source Redis instance. But you also don't need an enterprise grade cache in a small development environment for a startup doing a proof of concept. So it's really up to businesses to determine which type of cache is best for them and best meets their application and their business needs.
I'm going to push you a little bit here, John. We've got a lot of folks on our Truth in IT audience here, primarily, that are IT architectural thinking people. That who would have to make some determination of what's the right piece for the right part of the IT puzzle. So let's double click down a little bit and work back up through this. Let's start with basic cache. So if I get a basic cache, it's open source, I download it, I implement it. What am I protecting? What's the scope of that?
Yeah, definitely. So let's start with basic caching. A basic cache is typically a simple self-managed open source cache that's not supported by a team with a ton of experience. Maybe support and management is kind of done by a general support team with a best effort approach. So a basic cache is a great choice to support workloads that really aren't mission critical. They don't require resilience. They don't need high availability or skilled support. and they're not caching for significant amounts of data or really high throughputs. So basic caches are typically strong choices for development or QA environments. They're great for conducting proofs of concept or to support small grassroots projects with very low customer dependency and low user expectations around performance. So in looking at like some of the characteristics of a basic cache typically has the most limited open source functionality. It can be difficult to manage and to scale. There's no SLA for uptime. It's not highly resilient, and there's definitely a risk for data loss. And it's not managed or supported by a very experienced team. So while basic cache is often adequate to meet some of those less critical business needs, there are times where employing a basic cache can be problematic. As I mentioned, a lot of Redis projects start as grassroots ones, but as the number of users grow, the volume of data grows, the stack begins and the business begins to grow geographically and expand into new regions. Issues often arise around costs, around scalability, around operations, the data availability. So there's definitely a time and place for a basic cache.
All right. So when it comes time to step up to the next level of caching, you called it intermediate cache previously. What are the triggers for that? How do I know I need an intermediate cache? You just mentioned some things about scalability and usability, but and then what shape does that take when I'm going from a single open source cache to something better?
Yeah, great question. I mean, a lot of the time we see that our customers jump straight from a basic cache to an enterprise grade cache, but there is also this middle ground where a lot of our customers come from, and that would be an intermediate cache. So an intermediate cache is a good choice to support smaller business applications that reside maybe in a single deployment environment, like a single cloud, that don't have complex operational needs, and they're not dependent on sub-millisecond latency at all places and at all times. These intermediate caches typically contain some, but not all of the functionality needed to support, a mission critical cache at scale. These intermediate caches typically do well for smaller but scaling production applications that are hosted in a single cloud. Cloud managed Redis services like Amazon Elasticache, Azure Cache for Redis, and Google Cloud Memory Store are great examples of intermediate caches.
Okay.
Intermediate cache, but an intermediate cache could also be a self-hosted and managed on-premise by a team, providing that there's an in-house Redis operations team that's available to handle scaling, management, and support, and there's a degree of competency there. And these intermediate caches typically have limited functionality. They can be difficult to scale and manage, and we often see our customers outgrow the ability, the scalability of their intermediate cache. They're often limited to a single deployment environment, like we mentioned, with the cloud managed Redis services. They're limited to a single cloud. They often allow for a degree of downtime, which still leaves a risk for data loss. And they're often typically third-party or self-managed versions of open source Redis.
All right, so this is kind of like the center of excellence approach. If you've got an IT staffing that you can step up to, or you've got a service provider or cloud service provider service that's called caching, it's probably Redis underneath in most cases, it looks like anyway. But they're providing some wrapper around it to make it a little bit more production oriented, a little bit more plug and play, a little bit more of a utility, but not necessarily tuned for what you're doing, right?
Exactly. And they'll still handle some of the, especially with the cloud Redis services, they'll still handle some of the operational burden, but you're not getting access to teams that specialize in Redis, right? They're often running and managing lots of other technologies and cloud services as well.
All right. So let's step up now to the enterprise grade cache, which is sort of the punchline here today. What are we looking at when we say we're stepping up to be enterprise?
Yeah, so an enterprise grade cache is absolutely essential to supporting the most mission critical business applications at scale. It has all the functionality, support, and management needed to ensure that applications perform in real time at all places and at all times. They provide the resilience, the high availability, the expert support needed to safeguard against cache outages and make sure that real-time application performance is always available to customers. And this functionality protects enterprise applications from incurring high latency, lost data, and any of the damages to their brand reputation, any lost revenue, any of those types of penalties that result from cache downtime. And an enterprise grade cache does this by providing a full feature set. It can be deployed anywhere in any cloud, on premises, hybrid, multi-cloud. It's resilient and it's highly available. It allows for virtually no downtime. Failover is in seconds instead of minutes. An enterprise grade cache is really flexible and can deploy a unified data set anywhere. It maintains performance effortlessly at any scale. So you don't see these issues where maybe a lesser cache is performing at a smaller scale, but once the throughput or the data set gets too large, suddenly there's performance issues. And enterprise grade caches are often, they're highly automated and they're supported and managed by true Redis experts. So basically, an enterprise grade cache provides exactly what you need when powering the most mission critical applications at scale.
All right, so I'm sure we're going to come back to this in a bit of comparing, the performance capabilities and the increase in availability you get when you're stepping up through those levels of things. But I guess just a more fundamental question is, if I'm running an IT department or we're looking at an architecture or complex application, how do I know when caching becomes mission critical? How do I know when that is a piece I should focus some energy on?
Yeah, that's a great question. And as I mentioned before, right, there's different main types of caching, and they each have their own, they each have their own place, and they're each appropriate for certain business and deployment scenarios. So choosing the correct cache is a really important decision because there are significant business implications that come with an effective caching. So to your question, if you're thinking about your own architecture and your own application, here are some questions that people can ask to determine if their application may require an enterprise grade cache. So is the cache mission critical? Must the app perform in real time at all times? Is there any tolerance for downtime? Does the cache need to effortlessly scale? Does it need global reach while providing low latency and data consistency across all the different locations? Does the caching solution need to help reduce the cost of caching, especially at scale, because it can get really expensive once you get into the larger data sets? Do you need deployment flexibility, especially for these hybrid and multi-cloud applications? And do you require a solution that eliminates a lot of the operational burden of complex caching at large scale? So I think, if the answer to any of these questions is yes, then you should really seriously look into enterprise grade caching, because there's likely a lot of upside for your business.
All right, I'm sure we're gonna get into some of that in just a second. But what struck me about what you just said was, I kind of was thinking about a lot of those things, but global reach struck me, big data struck me. Those are things that in the past we might not have had to deal with caching solutions. We might not have thought that our little application was going to be used worldwide and over such large data sets, right? So I think it's creeping up on people too, right? This is something that they may not have needed a couple of years ago, and now they turn around and say, oh no, this is now, we need to be in this game.
Absolutely. And a lot of times we see with customers, maybe they have a cache that's performing well, but as they start to expand into new regions, there's a whole new issue with network latency, because they have infrastructure located in one region that's sending data all the way across the globe to a user that's using an app in another region. So an enterprise grade cache really needs to be able to be globally distributed for real-time reads and writes across the globe.
All right, and I just had this other thought too. Like, what happens when caching breaks? We know that there's some potential, depending on how we've architected, for performance impacts, right? There's some implication for that, but it can go a little bit deeper nowadays that we've got this complex global situation.
Yeah, absolutely. So there are significant business implications of inefficient caching. As you mentioned, it's not just the apps getting slow. Right. There are going to be some serious implications to both your business and your applications if you're not using the correct approach to caching. So ineffective caching can introduce some serious problems. One is cloud lock-in, which leads to vastly increased complexity. It can lead to problems with siloed data between different cloud environments or deployment environments, and operational challenges, because suddenly you're managing a myriad of potentially different Redis services in each cloud. There's also obviously the issue of application latency, as we just touched on, but applications that can't meet the performance needs of customers, they're just not fast enough, and they leave users and customers waiting with laggy applications, which is always a terrible look for the business and leads to terrible business outcomes. Cache outages and data loss are another impact of inefficient caching. Inefficient caching can lead to serious issues with the cache going down, which leads to slow application experiences, for customers, but it can also lead to data loss if there's data that was being written to a cache and then suddenly the cache goes down. It can lead to inability to support global deployments. An inability to deploy a cache globally with sub-millisecond read and write performance can introduce that issue we were just talking about a few minutes ago with network latency, which kind of defeats the purpose of caching, right? Because data now needs to travel from a database located in one region to a user across the globe for a read or for a write. And there's now an issue with network latency. Inefficient caching can lead to challenges with scaling. Difficulty scaling can hamper application performance, and it can cause problems with business growth. It can leave businesses unable to support the volume of customers and lead to poor customer outcomes. High costs are another challenge. RAM is very expensive, so caching inefficiently can lead to really high costs, especially at scale when there's a really large data set or high throughputs. And then finally, inefficient caching can lead to serious problems when a business outgrows their ability to manage or support their cache, which can lead to operational headaches, can lead to challenges properly scaling and deploying their cache, and can lead to the inability to quickly resolve and troubleshoot issues when a cache does fail and there's a production issue with your cache.
All right, so I'm sold, John. But now let's go back to Redis. What does Redis bring to the table now to be enterprise grade when we're talking about Redis being open source, Redis being provided as an intermediate cache? What is Redis bringing that's enterprise grade?
Yeah, absolutely. Yeah, so there's these real challenges with inefficient caching, and they can be overcome with an enterprise grade cache. But let's start with what an enterprise grade cache has to bring to the table to help overcome those challenges. So to start, it has to be fast. I think it goes without saying that any cache, especially an enterprise grade one, needs to bring incredible performance. It needs to provide sub-millisecond performance in all places and at all times. And that performance needs to be both for reads and writes. And it needs to allow you to provide sub-millisecond performance to any data type. An enterprise grade cache must maintain performance at any scale. And this is a huge distinction between a basic or an intermediate cache and an enterprise grade cache. These lesser caches may be fast in smaller environments, but they really can struggle to maintain performance at the larger throughputs and larger data sets that an enterprise often operates at. And businesses that need their caches the most often have much higher throughputs and much larger data sets. So you think about most enterprise use cases where speed matters. There are typically thousands of customers reading and writing simultaneously, and an enterprise grade cache needs to maintain its speed even at these peak loads. Enterprise applications use a multitude of data types. They support so many business use cases, from standard database caching to session management to machine learning feature stores to gaming leaderboards. And they're deployed all over the place in on-premise data centers or infrastructure, as well as hybrid and multi-cloud environments. And an enterprise grade cache has to be able to support all of these different data types, all of these use cases, and all of these deployment environments at once. So a piecemeal approach with different caches for each use case or each cloud or each data type introduces a ton of complexity, it fragments data, and it makes operations a lot more difficult. Because enterprise grade caches are built for mission critical applications at scale, they have to always be available. They really have to be built to withstand failure. So, think about the devastating impact of a cache outage to a bank that's using a cache to power real-time transactions, or to a gaming company using a cache to power leaderboards for thousands of gamers. An enterprise grade cache has to be highly resilient, has to be highly available, with an uptime SLA of at least 5 nines, which allows for under 30 seconds of downtime per month, which is virtually no downtime. And it has to have quick failover, or multiple primary caches with an active deployment to prevent against the business impact if there is some sort of issue. Enterprise applications support users, business units, and customers distributed across the globe. So an enterprise grade cache has to be able to support this reality. It can't be limited to one region. It can't not globally distribute writes, which is a limitation of an active passive approach. It has to distribute reads and writes. And it can introduce the issue of network latency as data travels from infrastructure hosted in one region to a user far away. To be a really enterprise grade cache, a cache has to offer an active approach that offers multiple primary clusters, two-way replication, and can really globally distribute reads and writes with data consistency and with sub-millisecond speed anywhere in the world.
No, good. I was going to ask you how much is this all going to cost?
Yeah, yeah. So real-time performance enabled by a cache does bring tremendous value. But yeah, Mike, there is a point. It come with a very hefty price tag. So to alleviate the high cost of RAM, an enterprise-grade cache should utilize tiering and multi-tenancy, and this really helps with the issue that enterprises run into, where maybe their Redis cache is it's affordable at a smaller scale, and then suddenly they've grown and they see their their bill and the cost of their infrastructure, and they just have this moment where they realize that they're in a little bit of cost trouble here. So tiering helps cut costs by keeping the most frequently accessed data in the faster RAM, while offloading less frequently accessed data to slower but far less expensive flash storage. And this enables an enterprise-grade cache to really significantly reduce costs by up to 80%. Without really hampering the application response times, because it can be smart about where and when data is tiered. It should also utilize multi-tenancy, which allows for completely isolated databases to run on a single node. And by node, I mean a physical server, a VM, or a cloud instance. And that ensures that the expensive infrastructure that an enterprise is buying is fully utilized, so they're getting the most out of it. And then a properly implemented cache, again, it provides tremendous value, but basically an enterprise-grade cache has to provide support and management by experts. It should be highly automated and available as a fully managed service by experts at Redis to help alleviate some of the operational burden of managing a very complex cache at scale, and to ensure that your business has access to the world's best at managing Redis. And not only is management important, but also support. So when speed is mission critical, an enterprise-grade cache must provide support from true Redis experts to ensure that the application performance is protected. And when the cache goes down, it's back up and running as soon as possible in the event of some sort of cache failure.
All right. So there's a lot of pieces there that make it enterprise, right? That have taken us from now that basic idea of the open source piece to enterprise. Any way to summarize that up for us?
Yeah, sure. I think actually Redis Enterprise is a great way to summarize that. Some of the features that we offer. Redis Enterprise is really the only true choice for enterprise-grade caching. It was designed and built by the company behind open source Redis as a full real-time data platform. Redis Enterprise delivers all of this functionality that we just went into. It delivers the speed and flexibility of open source Redis. It works with all of the core data structures and data models that so many Redis developers and businesses are familiar with. But it also adds on a lot of the enterprise-grade functionality that an enterprise-grade cache has to deliver. It maintains sub-millisecond latency at millions of operations per second. It provides unparalleled high availability with 99.999% uptime, which again is under that 30 seconds of downtime per month mark. It's highly durable and it was really built to withstand failure. It can deploy global applications with low latency for reads and writes with active-active geo distribution. It's cost efficient. It has multi-tenancy. It has tiering between RAM and flash, and it has highly efficient CPU utilization. It can be self-managed on premises or in the cloud, or it can be fully managed as a managed service in your cloud of choice. So it's very flexible. It's perfect for supporting those hybrid and multi-cloud applications that just about every enterprise is working with today. And it's available, fully managed and supported by the company behind Redis. So you have access to the automation, the innovation, and the expertise from the world's foremost Redis experts here at Redis. So it really takes that strong core of Redis and adds on a full set of features and expertise that are required to deploy mission-critical real-time applications at scale.
John, can you just help me understand, maybe with a couple examples of how people might have maybe started with caching at a more basic or intermediate level and then realized they needed to step up to enterprise grade?
Yeah, absolutely. Let's take a look at a customer of ours that was using an intermediate cache for Redis. They were using Amazon Elasticache. This customer is a global leader in customer engagement software with over 150,000 customers. And they were just seeing massive growth. They were seeing upward of 50% growth for 6 years. And this extraordinary growth led to them actually outgrowing the abilities of their intermediate cache. The increased customer activity was just straining the capabilities of their application architecture and their operations. So they eventually decided to come to Redis Enterprise. And Redis Enterprise offered them a fully managed database as a service that provided them with automated scaling, fast failover, persistence, and high availability. All things that a cache must provide when business grows to that next level. And choosing Redis Enterprise provided them with a cache that can perform at any scale. It helped reduce a lot of the operational burden and the operational troubles that they were experiencing, and helped lower the burden on their database. So they just had an absolutely tremendous outcome once they upgraded from an intermediate to an enterprise grade cache with Redis Enterprise. And then let's take a look at one more customer story.
Okay.
Except this one was using a basic cache. They were self-managing open source Redis. So this customer is a leading telecom company that offers internet, TV, voice, entertainment, and video to customers in Canada. So they have a digital TV service that heavily used open source Redis, especially to power its menu, its guide, its recommendations. And they were self-managing open source, and they were running into issues with outages that caused downtime. And that downtime was leading to the unavailability of key menu options and show recommendations. And not only were they, leading to, application outages, but they were also a huge headache for the team that was managing Redis. It was difficult for them to fail over and get their Redis back online when their open source Redis cluster did go down. So ultimately, they decided that their cache was mission critical to their user experience and to their business, and they decided that they needed to upgrade to Redis Enterprise. So once they did that, they not only received better performance, but with active geo distribution, they were able to deploy multiple primary Redis clusters distributed in different geographies. And that meant when another issue did arise, which did happen, it was completely unnoticeable to their application or their customers, and business really just continued as usual. And just as an added bonus, they also noted better performance and easier operations due to support from true Redis experts.
All right, so they got their performance, their speed boost, but they got some reliability out of it, some availability improvement, which is interesting to consider. So really, all those different facets you outlined before can come together. On this. I'm just wondering, though, if people out there are still looking at this, going like, "Well, what do I do next?" I mean, we've got caching. Should I do anything about it? If someone wants to learn more about Redis or learn more about looking at where their caching architecture is, do you have any resources for them? Would you point them at anything?
Yeah, definitely. I mean, if you want to learn more about enterprise caching or Redis, we have some great resources for you. So you can go ahead and scan the QR codes on the screen, or you can type the URLs down at the bottom. On the left side, this is great if you already have a cache already. You can take our quick and free caching assessment. So you'll answer a few easy questions to determine if your cache is basic, if it's intermediate, or it's enterprise grade. So that'll help put a lot of this into context for you and what it means to your business. And then once you do that, we'll send you a report that can identify potential risks and help you understand your strengths and weaknesses, as well as bespoke recommendations for better caching. And then on the right side, if you're looking to start caching with Redis, or maybe you already have Redis and you just want to learn more, check out our ebook, which is really like the definitive guide to Redis. And it's called Caching at Scale with Redis. So check this out. It'll teach you everything you need to know about Redis, about caching, about how to use a cache. It'll dive deeper into a lot of the cache patterns and strategies we've discussed. So these are two great resources for anybody that wants to learn more about Redis or about Redis Enterprise, or even just to kind of benchmark their cache if they're already using Redis and understand where it's at.
Awesome. I have to say, John, one of the problems I have in life is spelling caching, because I always get confused with the E and the I when I get to that part of it. Like that someone told me about it, I always have to look, how did we spell caching again when I'm typing? Thank God for
autocorrect. Used to it after a while. Yeah.
I think it's Redis. You guys are the experts in spelling caching. Yeah. So take a look at those. Thank you, John, for so much for explaining this to us. I hope the people watching have a deeper appreciation for the different kinds of caching at a little bit more of an architectural technical level now, and can take advantage of some of the resources that you've outlined there, and really consider how to really, in 2023, maybe this is the thing. How do I really ramp up what I'm doing with my IT architecture?
Thanks, Mike. Really appreciate it. And thanks everyone for your time today.
All right. Back to you, Dave.
All right, great job, guys. Thank you, Mike. Thank you, John. Thank you all for coming today. Thank you to Redis for sponsoring this event. I apologize, we went a little late. Thank you if you could stick with us, and we hope to see you at the next event. Thanks again, everyone. Dave Littman here at Truth in IT signing off. Have a great day.